Hi, here's the second continuation of converting my Mars 4 DLP printer into well, actually converting, or not a conversion, but adding a heater to my Mars 4 DLP printer, a heater and a cooler. So here's the next part of my conversion. Yeah. So anyway, I took off all the front panel here, so I can take this off. As you can see here, because I added this controller for the fan, which is the fan cooler and bat heater. So the resin that I had needs to have about 55 degrees Celsius warm. So that's gonna be a bit warm here. So it'll help the the resin to be more flowable, you know, not so thick. So it thin it out. And so when printing, it's easy to print, flowable, and then on a certain temperature, when it goes to 60 degrees, the fan will automatically turn on, and it'll the cover that we have here with Elegoo, it has an open a vent. That's actually for if you want to add an extra uh, filter for that. But I'm not going to make a filter out of that because this one already has a filter in it, a small one, but good enough. So I'll use that one as a vacuum to vacuum out the heat. So when it becomes to 60 degrees, it'll turn on to cool down to 55 to keep it 55. So if I'm doing a lot of cases, then eventually this will heat up a lot. So I need to cool it down. So that's I converted it already. The fan I bought was 12 volts, so I should have bought 24. So I can connect only to one because I'm going to drill a hole here for 24 volt conversion, which I will show you in a little bit. Because right now, one is 12 volts, one is 24 volts. So that is why my pin here is 6. Next time I'll be able only to put 4. So see, because there's an access hole underneath where there's a what you call this, the trip sensor for the height to control this when it goes up and down. There's a trip sensor there, and they've cut out a bit, so there's a hole there. So that's where I had access for my extra wire, and then this one just connects here. Now this pin has a knot. It has to lock in there, just kind of like notch. So what I did with that notch, or that bump, I grind it off so it's easily. So it, because if I don't, it's hard to take it in and out. So when I grinded that notch off, so now I can put in easily. In, see, it locks in and out, and then I can take it off easily. And then when you need to change it, so I can easily, yeah. So anyway, I'm not, the only thing that's moving is this one, so it's not gonna come out no matter what you do. Plus, when you have the cover here, it doesn't have much space for it to come out. So now I had to grab 12 volts from the inside, but the one inside is from the switch here, well, actually the plug is 12 volts, which is this side. So what I did was inside on the back side of that pin, there's a pin there. That's the positive, which is the load, and then the body, which is here, is the negative. So I just connected an extra one for when I plug it in. Automatically, this will have a 12 volt voltage, so I can run the fan cooler, which is 12 volts on it. So, I wish I could have gotten 24 volts because I didn't know how they made this circuitry voltage. So at least now I know. Now I can next one, or I might get another one. I can now connect 24 volts in it, and then have only one, because I'm gonna have a hole for 24 volts anyway. So it's a plug-in also, like this one socket. So I'm gonna do one here. So I can connect one, so I have only just one wire all through to run 24, and well, I bought a couple already of a 12 volt fan, so I don't want to spend another extra money. So the next one I'll do the same thing again, but connected to the other back side. So this one is connected to here in front, and then a wire to the fan, to the 12 volt fan. So if I can, I don't know, I'm gonna buy maybe a 24 volt fan. Then I'll just have one wire connected to here, and then the one connected to there. So not too many wires. So then I don't have to do this. So anyway, I took this off. There's a screw to take this off. There's 1, 2, 3 screws inside, and I took this off so that I don't have to peel the tape off. So I took this one off the screen just to be safe, because I'm gonna be drilling on here. Anyway, set this aside. Let me put this on the other one. And I need to put this safely there. Okay. Now, what do I need to do? This one, wiring. I know there's a lot of wirings, because this one had, so let me show you. Let me show you how it looked before before I changed that. Okay, here. So there's a there's a temperature controller. It's like $20 for 2 of them. So this is 12 volts. So in here, this is silver. So that silver is the sensor. Okay, now there's 4 more wires, and this is for the voltage, and this one is for the motor or anything that you're connecting, which is actually the the heater plates that I put, the heater plate pads that I put. Okay, or you can say it as a motor. So now to connect this, one of the red, okay, because there's 2 red wires now. One of the red goes here, one of the red goes here. Okay, now I'm adding a rocker switch What is a rocker switch? A rocker switch is like this switch. 3-pin switch. Okay. So there's gold a gold plated collar. Okay, and there's two silvers. The outer silver part is the load. Okay, and then this one is the negative. Okay, and then this one is connected to one of the red and one of the black or yellow color on this one, which is actually okay. Let me take this out. It's a little bit. So one of this has a red connect, or the one that's from the heater. So they're both red. So one red is connected here, one red is connected here. Now this gold is connected to one of them, but I will show you later. So this one, I know I have to draw a diagram, but I'll do that later and show it to you what the diagram is. So the outer part of the silver is the load, negative and also negative. But this middle negative is connected to one of this. Like if one of this is connected to the to the red and yellow, you connect it here, and then the negative from the power. Okay, so you have a from the wall socket or any socket. There's a positive there and there's a negative. So the positive there, which is the load, goes here, and then the negative, which is connect also here. So the the red and the yellow connect to here too. Okay, and then this negative also connects to here in the middle. Got it? So there's this black on here, the yellow and the other red connected to here, and then from here connect to the wall outlet to the negative side, and this one is the load. Okay, so this one, just one connected to the to the to the wall outlet also, and that also connects this one, the red. So the red here, the black here, with the yellow and the red. Okay, so from these two you connect to the wall outlet. This one connects to the wall outlet as a positive, and this one a negative to the wall outlet. Now the remaining ones, oops, so the remaining one, which is the gold is connected to here. Okay, because this yellow and black one are for the motor, which you'll be connecting. This one will be acting like a motor. So this one back is connected to here, and the remaining red is connected to here. Okay, so you got that remaining red connected to here. Okay, yeah, so that's it. And then you have a rocker switch which you can turn on and off. So this will light up. This is a lighted rocker switch, so for me to see if it's on and off. Okay, so that's the wiring that I did for here. Okay, so I'm gonna put two rocker switches here. So I bought this easy clip for that rocker switch. So this one is in the, as I said, the red and yellow, and this one goes to here in the middle. What's this one? Oh no, I changed the color on this one. This one I reversed the other one to the other side. Well, actually, the motor you can choose which one you want. It's a yellow and a black. So I'm just not taking this off because this is the power. So just to remind me that this is connected to the power. So all I need to do is connect directly when I build a hole, which is the positive and negative that connects to here. So then, I don't have to think about it. Okay, so I use the black to be here. Yeah. So I'm just connect this one to here. And this one. Oh. That black goes here, the red goes here, and another black and red goes to the power, to the actual voltage. Okay, so I don't know if you understand what I'm talking about, but hopefully you do. I know I have to draw the diagram, but I will change this later to 24 volts, 24 and 24. But I already bought, so I don't want to waste my money on converting that one. But anyway, yeah. So the fan that they have is you connect that, you buy that fan, the heater fan. They made a heater fan, but it blows air outside. So it's not going to hit the resin evenly because you're only heating the outer layer, not underneath. It's still cold. So that's why I didn't want to do that. So instead I converted to this one. So that's my conversion. So as you can see here, I run the wire through, so you'll be able to tell that when you convert yours, you can have your own area to run the wire. You can drill a hole here if you want. I didn't want to. If I drill a hole here, then that means I have to also cut an area on the cover, and I don't want to do that too. So I'm just gonna go with that hole and just connect this one, and that's it. Once it's connected, it'll heat up to the heat that I need the vat to be, and then I'll be able to print properly. Because right now, the one I had was only going up. The one that I bought was only going up to 42 degrees Celsius. Was warm, but not warm enough to really make the resin thinner. Because when it gets cold, it gets too thick, and it has a hard time printing. So anyway, thank you for for following me on this. Subscribe if you like it. I know if you need another diagram, I will show it later on another video that will be a little bit better than this one, but at least you have a concept on how to convert one of these guys, because the sprint ray that has that here costs about like $12,000. I mean, I don't have that kind of money. So anyway, converting this will be, matching to that price. Hopefully. Okay, thank you. And good night.